All right, so at this point in our careers, we have written polynomials given the zeros, and we have found zeros of quadratic functions. Here we're going to find zeros of higher order polynomials using a technique you've seen before, which is polynomial division. So we'll do a quick refresher here with example 1, make sure you read it, and then we'll tackle example 2 where we're finding zeros of polynomials. So example 1 is talking about a rectangular prism, which is like a shoebox type of shape. And it's saying that the height is x plus 2. And it's asking us to write an expression to represent the area of the base. So that would be the area of the top or the bottom of the box, right? So that would be this area it's trying to ask us to find. And it tells us that the volume is that, right? Well, volume of a rectangular prism is length times width times height, right? Or area of the base, right? Like that, area of the base times the height. Okay, so obviously if we have the height and we want the area of the base, right, area of the base is going to be volume divided by the height. So what we're going to do here obviously is we're going to take the volume expression and we're going to divide that by, right, and then this works exactly like division of just integers using long division, right? So I'm going to be like, okay, I need to multiply x times something to get x to the third. That's x squared. And x squared, you can do this off to the side if you want. By the way, these are definitely whiteboard problems where you have to practice showing your work. If I distribute that, right, I get x to the third plus 2x squared, right? Now, this is important. The way I want you to write this is minus that whole thing, right? Because that reminds me to flip the signs, right? So if you write it, for example, like this example I copied down here with like a minus minus, that's going to make you forget to subtract the 2, right? So the parentheses help you remember to do that, and then you're just going to subtract straight down, so these cancel out. That's what we want. And then negative x squared minus 2x squared is negative 3x squared. And then I'm going to bring down the negative 6x. Okay? And then I need to think, well, what times x plus 2 is going to give me negative 3x squared as my leading term? Well, that gives 3x, right? And then same thing, you can write this out if you like. If I distribute that, boom, boom, I get negative 3x squared minus 6x. And then again, I'm subtracting that whole thing. And notice this cancels out, and also this cancels out, and our remainder is 0. Okay. So my area of the base, which is what it's asking me for, is this expression, x squared minus 3x. Okay. So that is polynomial division. Notice it's just like division of numbers, and you should have done this in algebra 2, so this is a review. Okay, now let's tie this all together. So in this example, we're looking for the zeros of f of x, and we're given one of them, right? So notice we have f of negative 6 is a 0. That means x equals negative 6 is a 0, right? And that means my factor is x plus 6 is a factor. And what that means, of course, is if I take f of x and I divide it by x plus 6, it should come out nice and even, and this will help me find all of the zeros of f of x. So I'm going to do this step by step. Feel free to try it on your own and check your work, or just skip ahead if you feel confident on the process already. So I'm going to do x squared here because that makes my x to the third. And I'm just distributing here like I did up here, right? I'm just doing it in my head because most of you guys are doing that. And then I'm doing a minus. These cancel for me, and I get negative 4x squared. The most common error I see people make on these is the sign, so be very careful with this distribution part. Bring down my negative 16x, and here I need a minus 4x to get negative 4x squared, and I get negative 4x squared minus 24x. And when I subtract these, notice this is minus and negative, so be careful here. So these cancel, and I'm left with positive 8x right? And I'm going to bring down the 48. And then I'm going to do a plus 8 up here. And then I'm going to get 8x is 48. These are going to all cancel out. Boom, boom, remainder is 0. Okay, now we are not done yet. So what I just found, that f of x is the same as x plus 6 times x squared minus 4x. Now, my suggestion is to check if this factor will factor nicely. So I'm looking for two numbers that multiply to 8, add up to negative 4. That one does not work. And you can check, you can make your list of numbers that multiply to positive 8. None of them will add to negative 4. So make yourself this note that this does not factor. So what I will do then is I'll use quadratic formula, and I'm just going to be like x equals, and then I'm just going to plug it in, and I just care about this factor because that's the one I'm solving, right? Negative 4 plus or minus square root. And then I'm just going to simplify. So I'm going to get negative 16 on the inside over 2. So this is going to give me imaginary solutions. And when I simplify this, I'm going to get x equals 2 plus or minus 2i. So this is from my quadratic formula, but remember, we also had and x equals negative 6, and that's from my original factor here. So this particular polynomial had 2 imaginary zeros and 1 real zero. Now when you're doing the delta math for these, it's going to show you a different method called synthetic division, which some of you may be familiar with for algebra 2. Feel free to do it that way. I prefer this way because it's easier to see what you're doing. Synthetic division, it's faster to write, but harder to understand. So that is up to you. The last thing I want to note here is with respect to example 3. So this is solved for you. However, notice we have this negative 3 left over. That negative 3 is called a remainder. Okay, so this no longer gives us a nice polynomial. So the way that we would write our solution here is we'd say our solution to this division problem is our quotient here, what we divided out. And then to write the remainder, we just say plus negative 3 over x minus 1. And that's just what we're dividing by. So that's the way I want you to represent polynomial division with a remainder, is just like that.